Hello everyone, if you're watching this is Zoe Academy. You are just at the right place. Please consider subscribing. Now today we are going to look at a question on a NEC paper, Kenya National Examination Council, on topic orthographic projection. We are going to look at a question here. This is a paper from Kenya National Examination Council. Now this is question number 6 and it reads, the figure shows hexagonal pyramid with a hole drilled through a height. Use first angle projection to draw the plan and the end elevation from direction X. Now there is a distance here of a hexagonal part, 50 millimeters distance across the flats, and the cylindrical hole of diameter 30. Now first thing we do is we have to draw the hexagonal shaped part here, which is the plan. Now taking the radius of 25 millimeter, you draw a circle equivalent of diameter equal to the distance across the flats. So we draw this circle here. Now once we draw it, how do we come up with the hexagon? We have a straight edge that will form a horizontal plane. Then with a vertical edge, of course using a set square, it works well. We draw lines on the left and on the right touching the circle. So we can first of all draw this line, tangential, and this other side again draw the same line. Then now you tilt the set square and draw a 30-degree line touching the circle, supported by horizontal plane, and you tilt or you rotate and do the same on the left hand side. Now because our hexagon is symmetrical and regular, we can do the same thing on the top part or on the upper side. We are just drawing a hexagon because distance across the flats is 50 millimeters. Now again we have the cylindrical hole driven or drilled inside, which is of radius 15 millimeters. So we measure 15 and then we draw our circle. So this becomes the plan. Now we draw the relevant lines that are going to be visible using an appropriate pencil. So I'm using an ink pen. So let's draw this. Now the circular part should also be visible. We can make sure it's visible. It's important. It's part of the plan. So this is the whole plan. Now we can draw our front elevation. Of course it is in our question. So we just draw a plane here, horizontal plane. We can name it as XX. Then we project from the plan. We have projection lines meeting the plane, of course passing through to just give us the front elevation. Now the height is 70 from the question here. We measure 70 and just come and mark 70 from your ruler and you mark up here. Again this side. Then you join. Now because it's truncated, we look at where that is 40 millimeters, then we truncate it. So let's truncate at 40 and just complete. So we can complete. So now we can number our plan, and we can first of all draw this, the inner part, that is the circular part. Project it upwards, and then you draw hidden detail. This shows this cylindrical hole is drilled inside, so it's not visible from outside. So project first, and then you just use a hidden detail or a hidden line. So now we can number the base, which is the plan. Correspondingly, of course, up here to the front elevation, you just do the numbering. Now this middle one, you have to include it again. It's also visible on the front elevation, the middle part, or this edge here. And you can number it as well. This is 3 and 6. Okay, now this is the front elevation. We need to draw the end elevation from side X. According to the question, we are observing the solid from left hand side. We are calling it X. So what do we see? We need to project lines from the cutting plane towards the right hand side. So first of all, the top, and then of course this edge here, this point of intersection. Let's project a line from it. And the cylindrical points or lines that indicate the cylindrical hole are also going to be projected. Then also the plan, let's project the sides to the vertical axis horizontally. So there we go. And also this other top part, we do it the same way. And now let's see, once we have done this, you can now draw the circular part. You divide the circle into 12 parts. Let's just first of all transfer, project the circular part. Okay, now we can also project this other side to just give us the end elevation. So we project 1 and 5 as well. We project 2 and 4 and the center line. Let's continue projecting it up to number the last one. Now you can ensure they follow suit. Let them go upwards by again using a vertical edge. We can start with the center line, project, and these other lines follow suit. There we are. So we number again, this 1 and 5, and this 2 and 4. Leave alone X, I should not confuse, and this is 3. We have this other line up here which we were forgetting. We can also do it. Project it. This was a line we were almost forgetting. So now we indicate the points where we are going to have the top part of the hexagon visible. We just follow number 1 and mark 3 and 6. You look for 3 and 6. This is 6 and 3 from the plan to the front and then to the end. Now this one is 5 and 4. We look for 5 and we look for 4. All those points should be joined, so we can join them. This is how the hexagonal face appears from the right, the left hand side. If you observe this solid, the front elevation or this particular truncated solid, this is what you see. And remember, these other lines, edges are visible, so we have to ensure we include them. This one and this one here. Of course, 4 edges are visible from point X or direction X, and the base is also a solid line or an object line. Now we are done with this. Now ensure that the plan having the circular hole should also appear on the end elevation. So now we have to divide this circle here into 12 equal parts by using a 30-60 degree set square. We draw lines, 30-degree lines, double lines, and then also 60-degree lines, double lines, and 30-degree double lines. So this is 30, and then again you interchange and draw another 30-degree line. Remember, we have also the central. We can now number 1, 2, 3. Okay, we have the central line or the center line. We can draw it. So let's draw it. Good. Now we can renumber. Now this becomes 5, and this is 6, 7, 8, 9, 10, 11. Last one is 12. So project them to the axis of the vertical line and the horizontal in that manner upwards to meet the cutting plane, each one of them. So we can have the vertical lines, projection lines from all those numbers. And then we have 12 here, then 1 and 3 upwards. The same thing from the plan to the right hand side to meet that vertical line. So starting here, then we have 7 and 3, then we have 1 and 9, then we have 10 and 12. So you'll pick your pair of compass and stand at 5 on the front elevation and just do the curves from these points to meet the base on the end elevation. Just project the center line as well. These are the points the way they are. Now from here, let them move upwards to meet the top line. From the front elevation, the same lines to go on the right to meet to cross the lines on the end elevation. So now we shall be looking for each number. We can first of all number them. This is the first one is 2 on the front elevation. This is 2, and this one is 1 and 3, and this is 4 and 12, and this one is 5 and 11. You should not confuse with the ones you numbered at first. It's 5 and 11, and this other one is 6 and 10, and this other one is 7 and 9, and the last one is 8. Same thing on the end elevation. This is 11, this is 10 and 12, and this one is 1 and 9, this one is 8 and 2, this other one is 3 and 7, and this one is 4 and 6, and lastly is 5. So let's start with 2. 2, go up, meet the cutting plane, look for it on the end elevation. 3 and 1, go up, meet the cutting plane, look for 1 and 3 on the end elevation. 12 and in that order, come and mark. Look for 11 and 5, come, look for 11 on the end elevation and 5. Now 6 and 10 from the plan to the front to the end. In that manner, with the same procedure, we follow suit. And now the last point, which is 8, you mark it here. So with a free hand, join the points to give us the circular part. Thank you. This is all that we needed to draw.